Hi, everybody. I'm going to go through how to find the most basic atom in a molecule here. So this process is going to be very similar to what we did for finding the most acidic proton. Keep in mind, though, when we're looking for bases, we are not looking at protons at all. So what I want you to think about here is look for atoms with lone pairs. Okay, if it doesn't have a lone pair, it can't be a base. So just think about that. It has to have a lone pair on it. In some circumstances later in the semester, we'll see pi bonds acting as bases. But again, you've got kind of a pair of electrons that you can work with. An H is not going to do it. Just a regular neutral carbon is not going to do it. So just keep that in mind. So just like with the acids, we're going to draw out the conjugate acid of our base to determine which one is going to be the more stable conjugate acid. Okay, because again, we're looking for this situation here, the more stable conjugate base, or sorry, the more stable conjugate acid is going to come from the stronger base. Okay, so in acid world, the more stable conjugate base comes from the more acidic acid, and the more stable conjugate acid comes from the strongest base. Blah. Okay. Hopefully I don't get all those mixed up. Okay, so for this, we are looking at this example here. First thing I'm going to do is draw in all my lone pairs. Okay, so I have my lone pairs drawn in. So I'm essentially looking at three options here. I'm not looking at a million different protons. I just got three atoms with lone pairs on them. Then I need to draw out my conjugate acids for. Okay, so when I'm drawing out conjugate acids, instead of using a generic base, I'm going to use a generic acid. So I usually just use H+. If you want to keep things a little bit more realistic, your fake acid can be A with an H. Okay, so we're just going to have our nitrogen or our oxygen. We'll start with the oxygen because it's on the left. There we go. So oxygen lone pair to the H. Give those electrons to A. And then we've got our conjugate acid. Okay, so then I've got that positively charged conjugate acid. And again, just like with the acids video, we are looking at the charge structures. It's very, very hard to determine it when you're just looking at a neutral structure. All right, so let's go ahead and go to the next one. Okay, so we'll use H. We're going to use this nitrogen lone pair, give those electrons to the A. Not quite sure why it did. I only have three, so don't need to cram too much. Okay, so now that nitrogen is positively charged. Do I have any resonance here? I absolutely do. So I can move a lone pair up onto my nitrogen, leaving my carbon positively charged. Okay, then I have my other nitrogen has a lone pair that I can use for another resonance structure. And then that's pretty much where I need to stop. And I'm going to go ahead and make that a little clearer. There we go. Okay, so that's pretty much where I've got to stop. So let's go ahead and look at the last nitrogen. Okay, so then when I'm here, I need to think really carefully here. So I've got a pi bond nearby next to my positive charge, but if I move this, I've got two issues. One, I'm leaving the nitrogen at the top. Let's just go ahead and draw that out. I'm going to erase it right afterwards, but we'll draw it out for now. Okay, so let's try to figure out some formal charges here. So the nitrogen at the top, 5 minus 1, 2, 3, 4, so that's plus. Then nitrogen at the bottom, 1, 2, 3, 4, 5. Technically neutral. Okay, so two issues here. One, nitrogen up at the top doesn't have a full octet. And then the nitrogen down here has too many electrons. Okay, so two big issues here. So that one is not going to happen. That arrow is not going to happen. So that charge on my nitrogen is localized. Okay, so then we need to think about our options here. So I've got localized on an oxygen. I've got localized on nitrogen. And I've got delocalized on nitrogen, carbon, nitrogen. Okay, so if we look at this middle one, it's pretty obvious which one is going to be best. But if we just had the two on the left, what you want to keep in mind here is that that first rule A for atom is going to be important here. So oxygen versus nitrogen, which of those would rather have a positive charge on it? Definitely nitrogen, right? Because it's less electronegative. So we're still using the same RAO sequence here for our basic atoms. We're just looking at different charges. So you just have to think about, okay, electronegative atoms like negative. So oxygen probably doesn't want to be positive, right? So nitrogen would rather be positive. So it's going to be the better base. And that's a kind of theme that we'll see throughout our whole time. But if we look at the difference between localized on nitrogen and then delocalized between nitrogen, carbon, and nitrogen, that's going to be a lot more stable. Okay, so this is our most stable conjugate acid. So that means that this nitrogen is our most basic atom. Okay, and that's basically doing all of those steps where we thought about RAO, we thought about resonance structures, we did our comparison, and we came to our conclusion. Alrighty, so as always, hope this was helpful. Let me know if you have any questions and have a great day.